Hey everybody, this is Brad Dyke. This is just a quick video on the status of that Seagate Black Armour NAS-400 array that I tricked using basically M.2 to SATA bridge connection daughter cards, if you remember. When I used the 2.5-inch hard disks and I allowed them to do their requirements, it took 6 hours roughly, and then some, to get them to a point where they're ready to use. These guys were done in just under 40 minutes. Dramatic difference. And as you can see, it is a Seagate Black Armour NAS-400 series, and I put M.2 SSD on board with it. So I'm doing a little bit of improvisation with that. So because of that, I was able to successfully configure this system in a format that will do a good job. And I'm going to go ahead and put a temporary password in here because this will be blown away eventually. I'll put in the Google DNS services just to make sure that it is good. And at this point in stage, the device will now kick itself back over and will attempt to initiate the process over again. The Seagate Black Armour array, it's sitting right here. If you open it up here, you'll see that there are the daughter cards that are plugged in with the M.2 SATA 128 gig units, and there's one SSD SATA back there in the back that was taken out of its 2.5-inch container and was plugged in directly as a logic card. Okay, so we're now logging in, and I'm seeing two differences here. One, with spinning hard disks, there's actually a delay in moving from screen attribute to screen attribute. This delay is not nearly as pronounced as it was with the SSD drive. I'm sorry, with the SATA disks that are spinning disks in versus the standalone configurations of the SSDs, SATAs. Now, because of that, that tells me that there's disk interaction with the actual web GUI tool. And so I'm going to go over here, just take a look at what I've got in the disk manager side of things. It's not much space. You know, there they are. 4 119 gig allocations. All good. It does read the LCA, which is the local SSD orientation information, and identifies 3 standalone SSDs on the M2s. And of course it sees a solid state drive on the SPCC standard, which is really truly a SSD SATA standard, opposed to the conversion of the M.2s over here. So we are good. Now we can go over here now. And again, this is just like what I talked about on understanding operations. The first time you do this, ladies and gentlemen, you do it in a way so it works best for you, right? And in this environment, it automatically configured a RAID 5 configuration, but you can blow this away if you want and start over again. Learn, break it to learn it, then eventually begin to develop what we call an operational mindset. You have to have operations in everything. If it's your managed switches, operations. If it's your NAS storage capacity, like you see here, operations. You know, how to use quota management. Quota management is used to help you not go too far. Like, for instance, you have 344 gigs. Now with SSD drives and SATA drives in general, you never want to use all of their capacity because that causes problems for the SSD drives. So I would only allocate up to quota management of 300 gigs max, leaving the remaining 44 gigs just to protect the SSD drives effectively. You also need to make sure that you're up to date, which is your download management. And you need to go through these one at a time to learn how they all work. Again, I'm seeing really fast response times on the actual system itself, flipping over and over and over. And I'm checking to make sure our firmware is good, that we have all of our updates. Smart Manager, now that's going to be a problem because SSD drives, they don't technically run like spinning disks do. And so there's some logic out there that doesn't work yet. But Smart.2 is coming out, and when that happens, it's going to include the nature of everything from NVMe to IP. IP being there are new hard drives out in the industry that will connect via by IP addresses on a hard drive network switch. That's complicated, to say the least. But basically, in a nutshell, Smart is not really as good as it used to be because of the differences between non-moving parts and moving parts. But all in all, you can get these processes set up, ranging from your general configurations and so on. Now, one thing about this particular storage device is it has a share status that is going to be a little bit out of date. So if you're going to do NTFS, understand that you are going to be dealing with a standing TLC style issue. It's version 1 is what it is, and because of that, it's going to give you some grief, unfortunately. That's what the big problem is with the old NASs. With the newer operating systems, you have to make sure you're loading backwards to get the TLS standards, so that you have all the emulation states. I think it's called TLS. I can't remember off the top of my head. It's been so long. Now you can bypass that by not using shares. Instead, you can use iSCSI, and you can create a single pathway iSCSI configuration. And what I said by single pathway is, in this environment, we're not using both NICs. We're only using one network cable. And that would require 2 network switches from this device with 2 network cables going through those 2 network switches to the actual server that has its own 2 physical connections. And you would treat that as a storage network that has no connectivity to the outside world. And that could act as an alternative to the aging share capacity you could have out there. Or you can just do NFS. NFS is pretty functional. Don't do FTP, whatever you do. That needs to go away. FTP is just, no, that's not good. All right, so with that being said, the whole goal of this was to see how fast would this system change, and I was impressed to see that it did change. Not only did it change, overall, I would say it added about 20% more efficiency to the overall function of the boot drive state, which is, by the way, running off of the SSD drives, because that's how it works. The device writes all of this information from an image it has in memory, decompresses it, builds it on the drives, and that's why we can see the improvement on performance. Trust me, when you see this on hard drives that are spinning much slower, you're just kind of, looking at your watch here and saying, oh man, this is just killing me. But with that being said, impressive. I mean, you could really put some serious capacity on this, and that storage array could last you quite a while. All right, with that being said, one other thing to clarify. If you choose to use a NAS platform as an iSCSI device, then you're kind of treating your device like what we call a SAN. That's a storage area network. This involves creating LUNs, using fiber channel connectivity, 2 paths over 2 switches to 2 paths to the host. Why? Failover. One dies, nothing happens. You really have to take a real hit. And to lose both sets of your networks isn't very common. Now, the other part of that is the fact that with iSCSI, you have to understand, your little 8-port hubs, you can only use 4 ports. That's right. So if you have two 8-port hubs, 1 gigabit hubs, they're cheap, which means they don't have an 8 gigabit bus on the back end. They kind of share resources. So don't do any more than 4 ports off of an 8-port. With that being said, there's also one kind of switch out there, and that is the following: the Netgear or common denominator 16-port switch. When you're planning and designing your iSCSI almost like a SAN network configuration, remember that network switches, especially cheap ones, don't give the maximum return on the ports, even though they can emulate 1 gig or 100 gig, 100 megs, and so on. They're cheap, they're low end, but they provide you decent connectivity. If you're going to use 2 of those pizza boxes, as we refer to them as, make sure that you understand that you probably shouldn't use more than 50% of the ports. And if you can channel sect means the following. Channel sect basically means that you've actually got blocks of bandwidth here. Okay, we have 4 sets of 1, 2, 3, 4, 5, 6, 12 ports. 1, 2, 3, and 4 for a 48-port switch. So because of that, those blocks are actual kind of like channels. And it's smart to put 2, 4, 8, 12, and 16. Will spread out your bandwidth. You get as much out of that 1 gigabit port as possible. But don't do any more than 6 ports on a 16-port switch or 4 ports on an 8-port switch. And at that point stage, also make sure you check your cabling, that they are properly rated, because that is where you do see a difference between a Cat5 cable and a Cat5e cable. So those are a couple of little side notes I want you to know. Well, this is Brad Dyke. I just wanted to put a closure to the Seagate Black Armour NAS-400 saga, and I hope this was interesting. I did hardware side of the equation, and then I did the software side of the equation, just so that you guys could see what it would be like. God bless and have a great weekend. Bye-bye.